let's look at the last couple examples from the packet before we move into the next section on amortization. And a reminder that feel free to pause the videos at any point to try working on it ahead of time. It's actually a great idea to test yourself to see if a lot of these concepts are making sense and to see if you know what to do. And at this point, maybe after you've seen a couple examples like with these two, now is maybe a good time to try them out. But I'll go ahead and work on them now, um, just so you can check your answers if you want to. So example 9 says that asks if $10,000 is used to purchase an annuity consisting of equal payments at the end of each month for 4 years at 6% compounded monthly, find the amount of each payment. So instead of giving this one's a little bit backwards because instead of giving us the payments and all the components, it's it's telling us how much money was used to purchase the annuity, aka what's the present value, and asking us how much would the needed payment be, what would the needed payment have to be to formulate the annuity. So I didn't explain that very well, but essentially we could purchase an annuity with a lump sum. We could pay all this money and get a monthly payment uh, in response, which is kind of what we're figuring out here is what is R. And if we use the original um, layout here, again, since we're looking at the present value, which is our current purchase price is A, basically we know A and we know all the components. We know the interest rates and the time frame, which is everything that's involved in little a. So what we don't know is R. So we could write that as A is equal to R times A N P, but we could solve for R by dividing A by little a and P and taking that particular ratio. And all of this stuff should be known because capital A is the present value of the annuity, the complete payment up front, and then we would just need to divide by that specific number, which would be n evaluated at a evaluated n and p. So I'm going to go ahead and just plug this whole nasty thing of a mess in there. And also we need to know, well, what's p and n as in all the other cases. So little p, and I'm using the same interest rate for convenience, which is 6% APR. So if we divide that by 12 because compounded monthly, that would still be 0.005. And then n, um, we need to know how many years. It should say 4 years. So 4 times 12 is 48. And I could then plug all of that into this formula. And I'm going to be taking 10,000 and dividing all that. So it's going to be 10,000 divided by 1 minus 1.005 to the negative 48 power, all divided by p. And another thing is that if I take a number and I divide by a fraction, what will happen is it will flip and multiply. So when I'm dividing by the fraction, the denominator of the fraction will flip to the top. So what I'll get is instead of dividing by p down here, which I could do, it will flip to the top because it's a double division. So basically that will become, or if you want, you could just type in 10,000 divided by parenthesis that number and solve that first. But I'm just going to do it all in one step because. And so let's go ahead and throw that in the old calculator. And notice the parentheses that I'm using are, be very careful with them. And what I strongly suggest you do is check, try it yourself, see if you're coming up with the same answer. And if not, check your parentheses, check your various calculations in your calculator, because that is an easy spot to mess up. But that would leave us with $234.85. Which again is so what are we doing? What does all this mean? This would be basically what would each one of those payouts be in the annuity. So this would kind of like a cash flow. If we invest $10,000 up front, it's going to amount to 48 payments of $234 every month. And it's kind of a way of taking a large amount of money and spacing it out over time. And we're also still gaining interest from this, um, from that $10,000 as it happens, because we could look at, well, what how much does that amount to in terms of total payments, which is a lot, not a lot, but more than we started with.